Hi folks, welcome to day 2 on dividing. Yesterday we looked at dividing using long division, and it worked out pretty well for us. It was kind of a long and arduous technique. We did some practice from a sheet. Today I'm going to show you an alternate way that you can divide polynomials. Now this way tends to be faster, but it's also, like most shortcuts, not quite as thorough. So let's just do a little recap of what our technique was yesterday. Yesterday we would have said that the restrictions on this division are x can't be 2. We'd set up the division. It's 5x cubed minus 13x squared plus 10x minus 9. And it's being divided by x minus 2. And so I just go ahead and take 5x cubed divided by x. It'll give me 5x squared. Multiply it all back down. And I'll get 5x cubed minus 10x squared, and subtract the whole thing. And you can see that there are already things that might go wrong because we might make a silly little mistake. So if I subtract carefully, I'm going to get negative 3x squared. I bring a term down, and I get 10x. I just repeat the whole process, so negative 3x squared divided by x gives me negative 3x. Now I multiply that whole thing by x minus 2. And I get negative 3x squared, and I get positive 6x. And now I'm going to subtract again. Okay, and this is maybe a little safer. I'll get a 4x here, bring a term down, divide by x, I get positive 4. Multiply it back in, I get 4x minus 8. Carefully subtract, and I'm running out of room here. I'm going to end up with negative 1 as my remainder. Okay, r is negative 1. So in the end, the result that I'm getting is I get 5x squared minus 3x plus 4. And then you could say plus negative 1 over x minus 2. You can also call it, if you prefer, you could call it just minus. Yeesh. Let me try and erase this again. You could also call it minus 1 over x minus 2. Honestly, I like to frame it as addition and just put my negative up here. Totally up to you. So a lot of stuff happening there. It's kind of painful. It would be nice to have an alternate method. And here's the alternate method. It's going to require a little sort of table that we're going to make, or sort of chart. Okay. And I'm going to put just coefficients in this chart. And this is a little different method than your book shows, though it is more in line with what most books that I've read, at least, have shown. So here's what I'm going to do. I'm going to put my coefficients from the actual polynomial up top here. So I have 5, leave a little space, negative 13, leave a little space, 10, leave a little space, and negative 9. Okay. The other thing I'm going to do is show a plus and a multiply. Those are just to help me out to remember. Now in the bottom, the thing we're dividing by was x minus 2. We're going to put a 2 over here. Okay, it would be the number that would zero out the bottom. So instead of having to write x minus 2, I've just got coefficients now. And there's this neat little algorithm that I can use that will get me the same result that I used to have, but with less work. Here's how it works. So we set it up with coefficients over here, right, from the original. We set it up with a 2 here because we had x minus 2 over here. For right now, this all seems like magic. And now we're just going to apply this technique. I'm going to bring down this 5. That's going to give me 5. And I go 2 times 5. 2 times 5 is 10, and I put that up here. Okay, 2 times 5 is 10 and goes right here. The next thing I'm going to do is take these two numbers and add them together. That's why the plus is here. So I'm going to get negative 13 plus 10 is negative 3. And again, I'll take 2 and I'll multiply it by negative 3, and I'll just throw it up diagonally. So this will be 2 times negative 3 is negative 6. Let me just get rid of all those little arrows that I drew. Undo. There we go. And now I repeat. 10 plus negative 6, just this thing over here. I'm adding them, right? It tells me add. So I get 4. Okay, let me get rid of some of those extra things I drew. And I repeat the process. 2 times 4 gives me 8. I put that up here. And lastly, I just add up that last column. So I end up with -9 plus 8 is -1. Now, if you look at those numbers, and you look at the numbers in the answer over here, they're the same, right? I'm going to put some little dots here. Here's what I get. This last number is going to be my remainder. And these are the coefficients of my quotient. Now, sometimes people wonder, well, how do I know that it turns into an x squared at the end? Here's what you do. The original question had an x cubed in it. If you divide by x, the highest power that you're going to run into is an x squared. So for these terms right here, what it's telling me is that the answer is 5x squared minus 3 regular x plus 4 x to the 0 plus my remainder over x minus 2. That was less work than what's in blue. Maybe it seems more like magic. One of the big things that makes it easier is that now we're doing addition instead of this miserable subtraction over here. Like a lot of shortcuts, we lose a little insight into what is really happening behind sort of the process, but we get an answer really quickly. This technique is called synthetic division. It's a quick way for us to divide polynomials. So we'll do maybe 1 or 2 more like this just so that you can get the hang of it. Okay, here's another one for us to try. We could do it with long division, but let's try this synthetic division technique again because it may save us some time. So I'll make the little table. What goes in the table? First of all, the coefficients of this big polynomial up top. So 3, -9. That is a coefficient of 1 beside that x, so 1 and -4. Right in here, I'm going to put whatever would 0 out the bottom. So if I see an x minus 3 in the bottom, like I do right here, what I'm going to put over here is a 3 from this 3 here. X minus 3 is going to give us a 3 over there. All right, let's put in our reminders. It's addition instead of subtraction that happens along the columns. There is some multiplication that happens. Here comes the actual technique. Take this 3, pull it down. Now we go 3 times 3 and put the number just up here. So 3 times 3 gives us 9. And now I'm going to add this whole column up. -9 plus 9 is 0. All right, so you might think that would cause a problem, but it doesn't. We just repeat the process. 3 times 0 is 0, and put the number up here. Okay, let's get rid of some of those arrows, and we repeat. Add up this column now. So 1 plus 0 gives us 1, and I repeat. 3 times 1 gives us 3, and send it up here. -4 plus 3, add up that column, you get -1. We're really all done of the division. All that we need to remember is that that last number is a remainder. Okay, the first coefficient we run across is a 3 from right here, and it's going to be an x squared now because we started with an x cubed and we divided by x. Highest power is going to be x squared. We have 0x. We have 1 as just a constant, and we have -1 as a remainder. Now that looks a little bit weird to have the plus 0x, so we could also just put it like this. 3x squared plus 1 plus -1 over x minus 3. Oop, little ruler issue here. Let's try one more with a quartic. So on all these, there were restrictions. We skipped over it on the last one. Maybe we'll mention it here. X really can't be -2 as an actual value. It's okay that the number -2 is going to show up in the synthetic division, because when we write it in the synthetic division, we're not actually subbing in an x value. We're just writing a -2 because it has something to do with the division. All right, the very first thing you have to notice about this is just like for long division, you need a placeholder for every power. So there's no x squared, so we have to think of this as 0x squareds. There's an x. There also are no constants at the end. This is how we have to think about this question, whether we do synthetic division or whether we do long division. Let's set it up synthetically. So I'm going to write all those coefficients in. I'm going to write my reminders to myself that I'm doing plus and multiplication along the way. And here, since it's an x plus 2, you're going to write a negative 2 here. Okay. So it's always the opposite of this number that shows up on the bottom, or really the number that would zero out the bottom of this division. Okay, here we go. 2 comes down. Now we go negative 2 times 2 and put it up here. So that's negative 4. Good. Now we add up this column. Gives us negative 6. And repeat. Negative 2 times negative 6 is 12. So we're going to write it right here. 0 plus 12 is 12. And again, negative 2 times 12 gives us negative 24. Negative 24. And then we're going to add up this column. Now, I probably should have given myself more room. I can see already I'm kind of scrunched up. Lastly, I'm going to have negative 2 times negative 19, which is 38. And so 0 plus 38 makes 38. That's going to be our remainder. For a final answer, I'm going to have 2x to the 3. It'll be 1 less than the power I started with. Minus 6x squared plus 12x minus 19 plus 38 over x plus 2. Synthetic division is great if you're dividing by x plus or minus something. The reason we don't always use it is because you might be dividing by 2x plus or something minus something, and it doesn't work out quite as slickly, though you can hack it. Also, long division will work if you're dividing by a trinomial instead of just a binomial. So synthetic division is great for dividing by simple binomials. After that, you kind of need to get back into using long division. I am going to make the sales pitch, though, that this was pretty slick here. I'll do this same question in long division. Let's see how long it takes. In the end, after all that gory work, we end up with the same result. They're both just as good. Honestly, you can get pretty quick at doing long division too, but synthetic division can save you some pain. That brings me to the suggested practice for this. I think the best thing for you to do is just redo the division sheet using synthetic division rather than long division. So that would be the same sheet that you did yesterday. Maybe you just want to do the odd ones. Maybe you want to do the even ones if you didn't do the evens yesterday. Or maybe you want to do them all. If you're looking for some more in the book, you could check out 6ACE on 124 to 5. But today's real topic is just to get some familiarity with synthetic division. Good luck with the material, folks, and take care.